In Module 4, we're going to be learning about a lot of different concepts in geometry. So, because there's so many different concepts, I think it'd make sense to possibly watch all the video lectures before you start on your MyMathLab assignments. So, today's objective is to look at diagrams like this and this and this and see if you can figure out the measure of all the different angles in these diagrams. So, today we're going to be learning about angle relationships. So let's start right here. We know that angles are measured in degrees, and you can measure angles with protractors, and we won't be using protractors today. We're going to be looking at information given to us, and from that information given to us we're going to find the measure of angles. And there's three parts to an angle. We could start looking at an angle. You have a vertex, which is where the two rays that extend from this point here is called the vertex. So we have a ray heading out in this direction and a ray heading out in this direction, and that's our initial side, and this is our terminal side, and this is our angle itself. Now if you look down below that at that diagram, you can see a yellow angle right here, and the measure of that yellow angle is 50 degrees. You can see we go 0, 10, 20, 30, 40, 50 up in this direction. It's not 130 degrees even though it shows 130. It'd be 130 degrees if we started over here, if this was the terminal side of my angle and we wanted to know the measure of this angle right here. Notice that 130 and 50 add up to 180, and there's 180 degrees in a half circle because there's 360 degrees in a full circle, and we're going to be using that information today as well. Okay, three different types of angles we're going to be learning about, or sets of angles, are complementary angles, supplementary angles, and vertical angles. So let me grab my pen, and I'm going to make it a little bit thicker here so you can see it better. And let's go with blue. So complementary angles, it's a pair of angles that add up to 90 degrees. Supplementary, a pair of angles that add 180. And vertical angles are when two lines intersect. The opposite angles are vertical angles, and they also have equal measures, and you're going to see examples of all of these here right now. Now, we just talked a little bit ago that if we take and go in a full circle like this, that's 360 degrees, right? Well, then we know that from here to here is 180 degrees. So these two angles in this diagram are supplementary angles. They combine to add to 180 degrees. So this 140 degree angle plus this angle x have to add up to 180 degrees. So naturally then the measure of angle x, that's how you pronounce that, is 40 degrees. And the reason it's 40 is because 140 plus 40 adds up to 180. That's a real simple example of using supplementary angles. Okay, look at these two angles. Whenever you see this mark right here, when you see this little square right here, that means this angle is a 90 degree angle. So this angle, which is 62 degrees, plus this angle y, have to add up to 90 degrees. So if we take 90 and subtract 62 from it, we'd get 28. So the measure of angle y is 28 degrees, and that's an example of two complementary angles. 62 degrees and 28 degrees are complementary. They add up to 90 degrees. Okay, is there enough information in this diagram to find out what x equals? This would be a typical problem on your MyMathLab assignment, I believe. So, do you think we'd write x minus 5 equals 3x minus 7? Do those two angles look like they equal each other? They might, but I don't think so. They don't look like they do. But we do know that this angle plus this angle has to add up to 180, right? They're supplementary. So all you do is write down that x minus 5 added to 3x minus 7 equals 180 degrees. And that's how you'd solve that problem. Well, the rest is easy. X and 3x is 4x. A negative 5 with a negative 12 is a minus 12. Or I said minus 5 and a minus 7 is a minus 12. Equals 180. Now let's add our 12 to both sides to solve this algebraic equation. And we get 4x equals 192. So we divide both sides by 4 here to find the value of x. And we get x equals, it looks like it'd be 48. So the answer is x equals 48. So if they said what's the measure of the acute angle, the acute angle is the one less than 90 degrees, we'd put a 48 in for x right here. 48 minus 5 is 43. So the measure of this angle right here is 43 degrees. And up here we'd know that 180 minus 43 would be what that angle equals, or we could substitute a 48 in for x to find the measure of that angle. And we should get 137 for that. Okay, a little while ago I talked about vertical angles. I didn't say much other than if two lines intersect, you get vertical angles. So here's what I was talking about. Okay, these two lines intersect, they form an X. Well, that means then that the two angles on opposite sides of that X are called vertical angles, and vertical angles, the measures of those equal each other. In other words, they're congruent. So maybe these are 30 degrees. If that's 30, guess what? This is also 30. And if this one was 30, I bet you could figure out what this one is. Don't you agree that this plus this has to add up to 180? So this would be 150, which means this one down here is 150. So there's two sets of vertical angles in this diagram. This 150 and this 150 degree angle are vertical, and this 30 degree angle and this 30 degree angle are also vertical. So that's what vertical angles are. Question for you is there enough information to find out the measures of all four angles in this diagram? Well, if we use the information that we just learned a little while ago, is there enough information to find the measure of all four angles? Well, what do we know about this angle and this angle? They're across from each other when two lines intersect. In other words, we formed an X by having two intersecting lines. Those two angles are across from each other or opposite of each other, which means they're vertical angles. So that means they equal one another. So to solve this problem, we would set 4x minus 1 equal to 3x plus 10. They don't add up to equal something. They equal one another because they're congruent. So to solve that, let's we have variables on both sides here. So let's subtract 3x from both sides, and we get x minus 1 equals 10. Now let's add 1 to both sides, and that gives us, I'm out of room so I'll write it up here, we know that x equals 11. So that doesn't mean the angle measure is 11, it means x is 11. So let's put 11 in for this x right here. 4 times 11 is 44, minus 1 is 43. So this angle is 43 degrees, which means this angle right here is 43 degrees. And then we could find the measure of the angle adjacent to it, which means next to it. We could figure out the measure of this angle, because this 43 degrees plus this angle has to add up to 180, because those two angles are supplementary. And what would that be? I think it'd be 137 degrees, which means this one over here is also 137 degrees because of vertical angles are congruent. Okay, there's one last thing. Wait, there's two more things I've got to try to make sure I can get through to you before we run out of time here. Interesting things happens when you have two parallel lines. See the two blue lines there? Those are parallel. When they're cut by a transversal or intersected by that red line, we have all kinds of angles formed. We have 8 angles formed, and they have names. Okay, the pairs of angles have names. So angle 2, if I slid angle 2, if I slid it right down this red line, if I kept sliding that angle right down that line, it would fit perfectly right on top of angle 6. Angle 2 corresponds to angle 6. I'm going to say that again. Angle 2 corresponds to angle 6. So they're called corresponding angles. I bet you also agree that angle 3 would slide right down that red line and land right on top of angle 7. So those are also corresponding angles. And guess what? Corresponding angles are congruent. So angle 4 is congruent to angle 8 because they're corresponding, and angle 1 is corresponding to angle 5, so those are also congruent. Now, we also have things called alternate interior angles. Take a look at the two blue lines. Angles 3, 4, 5, and 6 are in between those blue lines. Angle 3 and 4 and 5 and 6 here are in between those blue lines. They're on the interior. Well, 4 and 6 are on opposite or alternate sides of the red line, but they're on the inside of these blue lines, so they're called alternate interior angles. 4 and 6 are alternate interior angles. 3 and 5 are also alternate interior angles. Okay? Alternate interior angles are also congruent. And then we also have what are called alternate exterior angles for obvious reasons. 1 and 7 would be alternate exterior because they're on the alternate side of the red line but are on the exterior of the blue lines, and 2 and 8 are also alternate exterior. So those pair of angles are all congruent. Now I guess I could tell you this. If I told you the measure of one angle, so if I told you measure of angle 2 was 40 degrees, you could figure out the measure of every other angle in that diagram. 2 slides right down on top of 6, in other words it's corresponding, so that would also be 40, wouldn't it? And then if 6 is 40, wouldn't 8 be 40 degrees because of being vertical with 6? And if 2 was 40, then 4 would also be 40 because of being vertical with angle 2. And then because of supplementary angles, if 2 is 40, then 1 would be 140 because 140 plus 40 adds up to 180. And once we know that one's 140, 3, 5, and 7 are also 140 due to all kinds of reasons. 3 we could say is 140 because it's vertical with 1. We could say 5 is 140 because it's alternate interior with 3. Or we could say it's 140 because it's corresponding to 1. And then 7 is 140 because it's vertical with 5. Or because it is alternate exterior with 1. There's all kinds of reasons we could use. So we're learning a lot of different terminologies now, and we're going to be using those terminologies to solve these problems here in a second. And I have 3 minutes, so the last thing we're going to learn here is this. The sum of the interior angles of a triangle is 180 degrees. So if I, in fact, I always did this in my geometry classes. I'd have my students cut out a triangle, and then I'd have them rip off angle 1 and set it on a line down here on a point. I'd have them put the vertex on a point. And then I'd have them rip off number 3 and take that vertex there and put it right on that point there. Then I'd have them rip off number 2, and guess what? When they ripped off number 2, it fit perfectly in the space in between. So that means those 3 angles, angle 1 plus angle 2 plus angle 3, does combine to add up to be 180 degrees. Okay, let's try to get through a couple of these problems. Here's an example of a simple one. What we just learned is the 3 angles in a triangle, the interior angles have to add up to 180 degrees. So because of that, we know that this is 80 and this is 40, so that's 120. So wouldn't we take 180 minus 120 to find out that the measure of angle X is 60 degrees? Because 60 plus 40 plus 80 all adds up to 180. On this diagram, we can see that, and we haven't talked about this yet today, but you might remember back in geometry that if you see these little hash marks here and here, that means those angles equal each other. Well, we know the 3 angles in a triangle have to add up to 180, so if I take 180 minus 114, that gives me 66, and this angle and this angle then have to add up to 66, and since they are congruent, because of those hash marks, it means the measures equal each other. Each one of those is 33. So 33 plus 33 plus 114 adds up to 180. So the measure of angle Y is 33. Bye.